Hi all, myself I am Dr.M Siva Ramkumar, innovator DTCFC.
Myself, Siddharth SV, pursuing BE Computer Science Engineering at SNS College of Technology.
Hi, I am Sujit Raghavendra. I am pursuing SNS. I am pursuing BE CSE in SNS College of Technology.
Hi all, I am Srivarsha MD, pursuing first year CSE.
Hello everyone, today we are going to see some key concepts in electrical circuits. We will be talking about Ohm's law and Kirchhoff's laws, and we'll use simple case studies to bring out everything to life.
Exciting. I have always been curious about the electricity works in circuit, especially the things like resistor and batteries.
Yeah, and I have heard Ohm's law but still get confused about how it really works. Can you explain, sir?
Of course, let's start with Ohm's law. It's a simple yet powerful equation that tells how voltage, current and resistance are related. The formula is V equal to I into R, where V is the voltage in volts represented by V, I is the current in amperes represented as A, R is the resistance in ohms represented as O.
Okay, so if I have a circuit with a 9-volt battery and resistor of 3 ohms, how much current is flowing through it?
Great question. To find the current, we can rearrange Ohm's law as I equal to V by R, where V is 9 volt and R is 3 ohm, so that I equal to 9 by 3 is 3 amps.
So, a 9 volt battery with a 3 ohm resistor will give me 3 amps of current. That's like a tiny power surge.
Yes, exactly. Now to make it clear, let's look at an example. Imagine a light bulb connected to a 12 volt battery with a resistance of 4 ohm. What's the current?
So I equal to 12 volt divided by 4 ohms is equal to 3 amp.
Correct. So the current flowing through the light bulb will be 3 amps. That's the power of Ohm's law in action. Now, what do we think would happen? What would happen if we increase the resistance, say to 8 ohms?
The current will decrease, right? Because the resistance is higher.
Exactly. As resistance increases, the current decreases for a constant voltage. That's why Ohm's law is useful in designing and understanding the electrical circuits.
That makes sense. So, I guess if I put a higher resistance in a circuit, a thicker wire, the current would be slower, right?
Yes, that's right. Now let's move to the Kirchhoff's law. There are two important laws here. First, let us talk about Kirchhoff's current law.
Isn't that the law about current being the same at different points in the circuit?
Exactly. KCL says that the total current entering a junction is equal to the total current leaving. So if there were wires meet at a point, the current flowing is most equal to the current flowing out.
Wait, so if I have a circuit with 2 amps flowing in a 1 amp leaving, where is the 1 amp?
Good question. That's missing 1 amp would flow out of another wire connected to the junction. It's like a river splitting into the different streams.
So, the current is like the water in a river, it always flows to where it's needed.
Yes, exactly. Now let's look at Kirchhoff's voltage law. This one says that the sum of voltage around a closed loop is always zero. Basically, the energy supplied by the battery is used by the resistor and other components in the loop.
So if I have a loop with a 9 volt battery and 2 resistors, the total volt drop across the resistor should add up to 9 volt.
Yes, the battery provides 9 volt and this energy is used up in across the resistor. If the resistor have 5 volt and 4 volt across them, the sum is 9 volt and this satisfies the KVL.
So, if the resistor had a combined voltage drop of say 10 volt, something would be wrong, right?
Exactly. That would violate Kirchhoff's voltage law. The total voltage drop can never exceed the total supply voltage in the closed loop.
Sounds like physics is all about balancing things out, just like life.
Yes, you can say that. To wrap it up, both Ohm's law and Kirchhoff's law are the fundamental tools to understand how current and voltage behave in circuit. They are like the rule book for circuit design.
Thanks, sir. This makes circuit feel a lot less confusing now.
Yeah, now I can confidently apply Ohm's law and Kirchhoff's law in solving circuit problem.
Now I just need to remember that current always flowing just like coffee in my morning cup.
Absolutely. Remember, with electricity, everything flows just like ideas in the class. So, thank you. Thanks for sharing your views on Ohm's law and Kirchhoff's law for this case study video. Thank you.